They spray our skies,
interact with the magnetic
chemicals.
Space travel is space. Mars rover is a complete.
Hi, I'm Rich Lund, and welcome to Debunk the Funk. In episode 1, we explored some of the ideas of the Flat Earth model, specifically how they try and fail at rationalizing the setting sun with their model. Flat Earth enthusiasts claim that when the sun sets, it's just that the sun has moved too far away from us to be seen, and that this has nothing to do with a curved Earth. We disproved that claim pretty effectively, I'd say, but you're welcome to go back to episode 1 and review it and evaluate how well you think we did. Today, though, we're going to look at another aspect of how the Flat Earth enthusiasts describe the sun's movement. And independent of our first episode, we're going to debunk that idea in a completely different way. Before going further, though, I want to mention something. As a high school teacher, I've mentioned to some of my colleagues that I was making a series that would take pseudoscience claims and evaluate them. They were into the idea, but when I told them what the topic is for the first few episodes, the Flat Earth idea, they gave me a really funny look. Do you even need to debunk something like that? Since that's probably a common response a lot of people would have who are watching this video, I just want to reiterate something. Debunk the Funk is meant to be a series that's going to help the viewer develop critical thinking skills and learn how to evaluate claims. I thought the Flat Earth model is actually an ideal place to start. Why? Well, my goal here is not to convince any Flat Earth enthusiasts. That's not what I'm trying to do. Instead, for the first couple of episodes, I thought it was a good idea to start off with something that has claims that are very easy to sort through and debunk. Start off with something easy in order to show how critical thinking works and how it can be powerful. Kind of like some easy training for some of the real stuff that comes up in later episodes. So yeah, I agree. Disproving Flat Earth goes beyond just kicking a dead horse. It's like kicking a 1,000-year-old mummy. But I think what's important in these first 2 episodes is that we can effectively debunk the same idea using 2 completely independent routes. If the Flat Earth idea had a major problem after our first episode, this episode is only going to compound on top of that. So if you saw the first episode, you're somewhat familiar with how just about every Flat Earth idea describes the movement of the sun. In their ideas, the sun is a relatively small object. It's also relatively close to our Earth, and somehow it travels around our sky just above their disc-shaped Earth, completing one cycle every 24 hours. How it moves, how it changes direction, and why it's able to stay up there in the first place, Flat Earth doesn't really talk a whole lot about that. But still, in looking at their idea, according to their model, there should be times when the sun is significantly closer to the viewer, and times also where it's further away. Well, in all of this idea, there's something then that their model predicts should happen, and it's actually where we're going to get our claim today. Here's the claim. As the sun visually moves across the sky, the visual size or diameter of the sun changes. If their idea is correct, this must happen. Well, does it? Let's ask Flat Earth. As I've said before, Flat Earth enthusiasts have many videos out there. And actually, this topic, whether or not the sun changes size in the sky, is not a topic that they shy away from. There are many videos on YouTube that I can find that attempt to show what they consider to be empirical evidence of the sun actually changing size as it travels across the sky. Usually as it's either rising or setting. So what's going on here? Well, I'll tell you what's going on. These videos are trying to measure the diameter of the sun with a very inaccurate tool, an unfiltered camera. It's as if the makers of such videos are completely oblivious to some very basic ideas in photography, such as glare, contrast, aperture. This is some really, really basic stuff. Look, the sun puts out an intense amount of light. And whether we're on a spinning globe, or even if we were on a flat Earth, when the sun's directly overhead, that's when it's passing through the least amount of atmosphere. Meanwhile, if it's on the horizon, in both models, that's when the light coming from the sun is going to be passing through the most atmosphere on its way to the viewer. And atmosphere filters out a lot of that light, causes it to scatter. So if you take an unfiltered camera and you point it at the sun at, say, high noon, the intensity of that sunlight is going to cause things like contrast and glare to make the sun look much larger than it really is. As the sun sets, or rises, and that light is passing through so much more atmosphere, since a lot of that light gets scattered and filtered away, it is not so intense that the camera gets blinded by it. And so there's a lot less glare and a lot less problems with contrast. And this is also why a lot of their videos involve the sun starting to set or the sun having just risen. Thing is, even as the sun starts to set, there's still more and more atmosphere it's passing through as it's getting closer to the horizon. And this is what's causing the apparent change in their diameter size. It's just due to camera glare. But how can I demonstrate that to you? Well, I don't need thousands of dollars worth of astronomical equipment. I just need this. And I made this last year for less than $7. You could make one too. With just this tool, we can measure the apparent size, the diameter, of the sun throughout the day and test out our claim. Let me show you first though last year's footage and how I made this, in case you want to make one too. That way, you can reproduce our experiment and see if you get the same results. Alright, for starters, these are my solar viewer glasses. They're like your old school 3D glasses, but instead of having red and blue, they've got built-in solar filters. These are about $2 online. Anybody can go buy them. What these can do is block out the overwhelming majority of light. Only the most intense light can actually get through. So you can see, if you put them in front of a light bulb, there is still enough intensity to be able to see some of what's going on. They block out so much light that when you look at the sun with these, you can actually see the edge of the sun. Anybody who's doing any measurements of the sun's size should be using solar filters. Now, I'm going to be able to see the edge of the sun, and thus I'll be able to see the actual size, but the thing is, how am I actually going to make a measurement? That's where these little screen patch kits come in. We got a tiny little grating here. We're going to be able to use this to inadvertently measure the visual width of the sun. Now also, to help standardize some of this experiment, we're going to use a little bit of this whiteout, just a dab. We're going to cover one of the central boxes. That way that can serve as my central square that I'm going to always try to put into the center of the sun. And then just for convenience sake, once we're done, we're going to tape that screen to the glasses. That way it won't be moving. I got a little piece of plastic bag under here just to make sure the whiteout doesn't get anywhere else. Choose a mostly central square here, and just a little dot. Okay, now we let that dry, and when we're done, this will be the central dot that I'm going to try to line up into the center of the sun every time we shoot. And that also means, since this will be taped in position on the solar viewer glasses, it's never going to be rotated one way or the other. We'll always be using the same horizontal row. We are already dry. That didn't take long at all. Okay, next part. Gotta fix this to our solar viewer. There you have it. We are ready to measure the sun. So with our measuring tool in hand, last year, August 18th, 2016, I went to the same vantage point at 3 different times during the day, and I measured the sun's diameter. And now I offer up to you, for your consideration, the experiment. Sunrise! We're up on a parking structure on MSU campus, and the sun rose about an hour ago. It's currently 7:45 a.m. And I got my camera set up pointed right at the sun. Now, in order to show you what's happening, I'm going to have a split screen so that way you can see that I'm using our measuring device, and you'll also be able to see what the results are. We're going to do the experiment. We're going to do it here in the morning. We're going to do it in the afternoon, around midday. We're going to do it again in the evening. And then we'll go back and analyze the data. You can see also with the camera that when I have the solar viewer in place, put it in place, depending upon how the camera is focused, we can get a different sized sun, and we don't want that. So autofocus while recording is going to be turned off. That way we can get a constant focus, same size, standard size for each experiment. So I'm going to bring the lens all the way out, and I've got the focus all the way out. When I do that, I'm able to see both the sun, and I'm also able to see the grating on the screen. So according to the flat earth idea, the sun is relatively close to the coin-shaped earth, and in the morning, when it's just risen, it is quite far away compared to where it will be at midday. Let's go ahead and take a measurement. There's my grading. Now we're going to move the screen so that way that little whiteout dot is right there in the middle. That's pretty good. A little bright in my eyes to be able to count how many boxes wide it is. But we'll analyze this data when we get back. Just to show again what I'm doing here. There's the grading. There's the grading. You can dip down, see the sun is right there. There's the grading. There's the sun. There's our horizon. And it's still August 18th, and we're going to go back at 1:41 p.m. today for solar noon. That's when the sun is the most overhead it's going to be at your latitude. Midday. Back on the same roof. Where you at, beautiful? There you are. Gonna wait for some cloud movement, then we're good to go. All right. We're about 20 minutes past midday. Had to wait for some clouds to move. We're back on the same roof on MSU campus. I'm hitting record on my camera now. And you can see now the split screen that we have going on so you can see what we're doing. Now I'm also going to verify for you that I'm going to set the same focal length that I did for the first measurement. So I'm rotating the focus all the way to the same focal length that we had in the first measurement taking. You'll also be able to verify that it's the same because the screen grading will look the same as it did in the earlier morning measurement. Now I'm going to move the camera. I'm going to go straight up towards the sun, which is really bright right now. There it is. I'm going to be on the left, so I want the sun a little bit on the right. Okay. Now, place the screen over it. You can squat really weird while I do. Try to find that central whiteout one. The whiteout square. Oh, there it is. Okay. We are about in the center. The measurement has been taken. Okay, we're back on the same parking structure. It is currently about 5 to 8 right now. And we wanted to get here just a little bit early so we could catch the sun. It's been a good 6 hours and then some since we were last here. According to the flat earth model, the sun should have moved significantly further away from us. So we're about to take a measurement right here, right now. Again, I'm going to focus the camera the same amount that I had before. And now, we're going to take the measurement. Here we go. Right on there. As the contrast comes in, it focuses. All right. Find the central dot. There it is. And it is right there in the center. Now, if it's not immediately clear to you how this drives a stake through the heart of the flat earth idea, well, don't worry. We're going to go home and talk about it a little bit. Let's look at the data. Now, flat earth enthusiasts love to talk about how they so much trust empirical data, as anyone should. Well, that's exactly what this is. In all three images, we are using the same camera with the same lens positioned at the exact same focal length. If the flat earth idea of how the sun moves is correct, we would expect that near sunrise and near sunset, the apparent size of the sun should be the same. But what about at solar noon? That's when, according to their model, the sun should be significantly closer to us, and thus significantly larger than at the very start or at the very end of the day. Is that what we are seeing here? Feel free to pause the video and count the boxes across the screen patch. That's also again why we have the dot there in the middle. You can be counting the exact same row of boxes. At all 3 times of the day, the sun's visual diameter is the same. So let's go back to that claim. As the sun visually moves across the sky, the visual size or diameter of the sun changes. No, it doesn't. Sorry, that's just false. This claim has been quite easily debunked. Now, just as before, did I just disprove the entire flat earth idea? If you remember what we said last episode, we brought up that there isn't just one flat earth idea. There's a whole collection of just disjointed ideas. And disproving just one part of it doesn't mean all these other parts equally got disproven. But still, every flat earth idea that I've ever encountered involves the sun moving in such a way that it would have to change apparent size in the sky. And we have shown twice now that the sun just is not moving like that. Their claim just does not match the evidence. How the sun moves is a major idea to any flat earth idea that's out there. And I would say the model doesn't work anyway. But if we just used 2 different independent paths to disprove that the sun moves according to their ideas, their model already is bankrupt. Now also, did the findings from last year's experiment prove that we are on a spinning globe? No, it didn't. But the question to ask isn't whether or not it proved it. The question to ask is this evidence in conflict with that idea? Or is it actually helping to support that idea? As the Earth rotates, yes, the viewer would be moved closer to and then eventually away from the sun. The thing is, that distance of moving closer and further away as our globe rotates is completely insignificant to the 93 million miles of distance between the Earth and the sun. It's so insignificant that we would expect, just like what we saw today, that there's no noticeable change in the apparent size of the sun throughout any time of the day. So we debunked the flat Earth claim, and at the same time, the evidence that we collected is completely in line with our modern understanding of the solar system and how it works. Okay, we're going to leave flat Earth alone for a little bit. In some of our next upcoming videos, we're going to actually take a look at logical arguments and how they work. And also, we're going to review some indicators as to how an argument can be flawed. So keep an eye out for those. If you enjoyed this video, we always appreciate that thumbs up like, and be sure to subscribe to the channel for some more upcoming Debunk the Funk. I'm Rich Lund, and I'm here to remind you, the world needs critical thinkers. Make sure you're one of them. Later.